Okay, today we're doing section 2.9, absolute value functions. An absolute value function is a function whose rule contains an absolute value expression. So it's an f of x equals something with an absolute value in it. The graph of the parent absolute value function, f of x equals absolute value x, so that's your parent, is f of x equals absolute value of x. Its shape is a v. That's your parent function. So its minimum point or its vertex is at 0, 0. So to graph the parent function, I'm just going to plug in some numbers and show you that we get a v for the parent. Our function is y equals absolute value x. Plug in a negative 4. Y equals absolute value of negative 4, which is 4. So negative 1, 2, 3, 4, positive 1, 2, 3, 4, I put a dot. Y equals absolute value of negative 3, which is 3. 1, 2, 3, 1, 2, 3, put a dot. Okay, y equals absolute value of 0, which is 0. And the absolute value parent function is actually a reflection over the y-axis. Absolute value of positive 3 is still positive 3. Absolute value of positive 4 is positive 4. So we get a dot and a dot. And if we draw a line, our absolute value parent function is a V shape with the vertex at 0, 0. So we learned how to transform linear functions earlier this chapter and last chapter. We can also transform absolute value functions. So the general forms for translations are vertical, okay, up and down. We add a k. So if we go up, it'd be plus k. If we go down, it'd be plus a negative k. Okay, down is always going to make that negative, up keeps it positive. Horizontal goes left and right. And if we go left, we're going in the negative direction, so we would plug in a negative h. If we go right, we're traveling in the positive direction, we plug in a positive h. Example 1, translating absolute value functions. Perform the transformation on f of x equals absolute value of x, the parent function, then graph the transformed function g of x. And we're going 5 units down. So k equals negative 5. Our answer is g of x equals absolute value of x. We're changing the output, so it's absolute value x minus 5. We're going down 5. 1, 2, 3, 4, 5. There's our new vertex. Okay, our slope does not change. You would get a straight edge to draw yours. It's hard to do on an iPad, and there is your answer. Another example. We're going to transform the function 1 unit left, so our input changes. Okay, at h, let's erase that, h equals left, so negative 1. If we plug that in, g of x equals absolute value x minus h. h is negative 1. G of x equals absolute value x plus 1. And that just moves our vertex 1 to the left. And get a straight edge out and draw your new line. Pretty simple. Okay, you try. Push pause and go ahead and try it, and then push play and check your answer. There you go. You try the next one. Push pause. There you go. Again, you'd be using a ruler. Next example. Because the entire graph moves when shifted, the shift from your parent function determines the vertex of the absolute value graph. So, our parent function, if we transform left or right or up and down, we get our new name, x minus h plus k. Our vertex, where the point is at h, k. Okay, which used to be xy, we're now calling hk. H is horizontal, left and right, so we're replacing that for x. K is vertical, up and down, we're replacing that for y. Let's try to use this information. First example, translate your parent function, so the vertex is at -1, 3. That is h, k. So we're going to plug those numbers in. Easy as that. G of x equals absolute value x minus a -1 plus k. I plugged them in exactly how I saw them. We can simplify next. So that's x plus 1 minus 3. Now graph it. I'm going to push pause to graph. So to graph it, I graphed a vertex at -1, -3, and drew the exact same slope of the previous line. Alright, you try this one. Same thing. We have h and k. I'm going to push pause and you go ahead and try it. There you go. Alright, absolute value functions can also be stretched, compressed, and reflected. Okay, we haven't done much reflecting, but if you remember, reflection across the x-axis, your output changes. Or across the y-axis, your input changes. A vertical stretch or compression, you multiply on the outside, your output changes. Horizontal stretch or compression, your input changes. Horizontal were the hard ones, vertical, easy ones. Okay, let's try this first one. Perform the transformation, then graph. Reflect the graph of f of x equals absolute value x minus 2 plus 3 across the y-axis. Let's try to graph f of x first. And the first thing we do is look for our vertex. Our vertex is at h and k. H equals 2, k equals 3. So let's draw f of x. 1, 2, 1, 2, 3. There we go. Straight lines going up, and I'm cutting those boxes right in half. That's a slope of +1 and -1. Super easy to draw. Now, across the y-axis, or reflection across the y-axis means that our input changes. So g of x equals absolute value, my input changes, x minus 2 plus 3. And our new vertex is -2, 3. And with a little manipulation, if you did some input, some plugging in x's and getting y's, you'd see that your new vertex is actually now -2, 3. Your x value changes, your input goes negative. I'm going to graph that in orange. Okay. -2, 1, 2, 3. And if you just count it over, 1, 2, 1, 2, this is 1 away, 1 away. Okay, this is 1, 2, 3, 1, 2, 3. You'd see that you're reflecting it in orange. So the reflections across the x and the y-axis we're actually going to graph. Okay, let's try another example. This says stretch and graph. We are not graphing any vertical or horizontal stretches or compressions. We're just working through the equations. So in this first example, we have a vertical stretch by a factor of 2. And if you remember, this is how you work those. It's your output that changes, so you multiply a by your old function. 2 times the equation absolute value x minus 1. So g of x equals 2 absolute value x minus 2. And you have your answer. Okay, let's try the next one. Another example of transforming absolute value functions. We're compressing a graph. We do not need to graph it. We're just working through the equation, but we're doing it horizontally by a factor of a half. These types is where we change the input. Okay, it's horizontally, so our input changes. And we have b equals 1/2. So 1 over b equals 1 over 1/2, which equals 2 over 1. So in our input, we're going to have 1 over b x plus 2 minus 1. That is 1 over bx right here. So here we have our answer. Okay, this one is actually a you try. We're going to try it together though. Perform the transformation, then graph. Reflect the graph of f of x across the y-axis. So here I have a negative in front. That means my absolute value graph is actually going to open down. My vertex, same thing, I'm just going to pull it x minus h plus k. So 4, 3 is my vertex. So let's graph our original function first. Here you've learned that if there's a negative in the front, it opens down. The vertex you already know. 1, 2, 3, 4, 1, 2, 3. So my original f of x is going to be in blue. And to perform a reflection across the y-axis, our input value changes. So our new graph okay, and our new vertex is going to be our x value changes. I'm going to graph that in orange. 1, 2, 3, 4, 1, 2, 3, 4. Same slope. Make sense? There is your answer. Alright, you try this one, push pause and get the answer. There's your answer, whether you try on the next page. That's it, there was another you try here. All done.